So I volunteer myself to be a moderator of today, partly also because like Mr. Li is a good friend of mine. Maybe I can share with you here my little story about the work that Mr. Li and I are working on in Shenzhen. So Alicia, if you can go to the next page. Yeah. So on the screen here, it is a small project that we are doing in Shenzhen. It's only about 100 meters tall, you know, in KPF standard, it's really short. And it's an office building, but in a new district in Shenzhen, in a place called Shekou. If you take the ferry to Shenzhen, you might probably be landed in this neighborhood. This building itself is 100 meters tall, but it is located in this brand new area where all the landmarks that are building are like 200, 300, or the tallest is like 380 meters tall. So we are not the tallest, and we can't really call ourselves a landmark building. However, all the projects in our office are of equal importance, no matter of like the size, whether it's big or small. And we don't take any project lightly. So the goal for this project is really to develop a curtain wall system that are sophisticated. So through this like thoughtful and sophisticated design of the curtain wall, we want to deliver something that is to a building that originally is thought to be like pretty normal standard background buildings. So if you go to the next page, like you can see the massing itself is pretty straightforward. And we also like the plan is also very simple. A lot of the efforts is spent on the crafting the exterior wall. So what did we do to the tower curtain wall then? What you're looking at here is the major wall type. In this major wall type, what we have is an aluminum panel that's projected and bent and with a curved angles on the top and bottom. If you go to the next page, yeah, you will see like there is details and a model shot of this model. What you see here is like there is this like bent curve and also like a flat panel and then a bend. I mean, the projection has to do with like trying to integrate the required operable window for ventilation to the building. What we are thinking when we are designing this aluminum panel on the curtain wall, what we think of like a high-end glossy finish, almost like a car finish. If you go to the next page. Yeah, so that's what we have in mind. We are imagining that as like a black, like a highly polished finish, almost like a piano finish or like a posh black color finish. And through the changing of the sun angle in relation to the curved panel, so we want to create this sort of like three-dimensional qualities to this wall. So, I mean, then the question is like, what is this like coating to the aluminum panel that will create this sort of like piano finish? So on the left here is what we normally call the PVDF exterior coating for aluminum. And on the right here is what we started off with, which is called like a coil coating. Like a coil coating is as Mr. Li is going to explain more in his presentation. But what you're seeing here is the difference. If you can look at the reflection of the lights that we are seeing at the top part of the samples, like how details the conventional fluorescent lamp is being reflected on the right versus the one that is on the left, which is much more diffuse. So this is the first of all, we realized that like the different types of coating does have a different effect to your aesthetics of the panel. Okay, if you go to the next. So, and then of course we test out like different companies maybe I'll be able to offer like different types of PVDF coating and trying to compare the difference. And we go into like almost a year of research about these differences in coating. We thought like, okay, to start with, maybe we should start with like a coil coating for this panel. And then if you go to the next. So we did a mock-up. So this is, just excuse me for the really chaotic and messy like construction site behind it. Like we were so excited when the panel shipped to the site. We don't even wait until it was erected. I mean, we'll just like open the wooden box and then just looking at the panel. So what you're seeing here is the coil coating finish for the panel. But with the coil coating, I mean, there's a limitation of the maximum thickness. I think it's about 1 millimeters. So what you're seeing here, I mean, if you go to the next, yeah, you start seeing the reflection of the panel, which is exactly what we are looking for, which is highly reflective. And it also like plays around with the curves. However, we also realize that by specifying a coil coating, we run into an issues because because you coat the panel first and then you assemble. So I end up have to live with like all this like thickness of the aluminum panel, which is like silvery in color, which is not what exactly we want. Like we want something that is completely like flat and black. And so that becomes another issue because like coil coating doesn't allow you to assemble the panel first and then spray on it. So, and then we went back to more discussion with Mr. Li about like, okay, if that is not possible, what can we do? And then through Mr. Li, we got introduced to another coating called the FEVE coating, in which, yeah, is not as good as a coil coating as what we want, but on the other hand, it does still being better than like a traditional PVDF coating in terms of reflections. So, so we went back to drawing board and then we redesigned the details. And then the advantage of this FEVE coating is it allows the panels to be assembled first, and then you apply the coating on it. So next. So this is still something that is ongoing. What you are seeing on the screen is highly confidential in a way that it is still a work in progress. Is showing like another mock-up. So what you are seeing here is a FEVE coating compared with the PVDF coating in the middle. And so we are still like in the process of exploring and trying to deliver the shiny, like almost piano type of a coating that match with the design intent. So that's my little story about coding and so with that, I'm going to hand it over to Mr. Li to tell us more about the good story about coding. Thank you.
Yeah, thanks, Florence. Well, welcome everybody to Sherwin-Williams coil coatings presentation. I'm your presenter, Shu Li. So thanks for joining me today. Well, as far as now, Sherwin-Williams coil coatings, we are still the same great brand that you know and trusted before. So for your exterior facade, now we're just bigger and able to provide you with even more coating solutions. It is important to, to clarify exactly what Sherwin-Williams coil coating does. Okay, since we are part of the large international organization, and you're probably already very familiar with your local Sherwin-Williams consumer paint stores. But as it relates to you, the architect, there's several divisions within Sherwin-Williams that you may work with to specify paints and coatings from interior to exterior, including walls, ceilings, floors, and building envelopes, which is specialty for coil coatings. So today we are talking specifically about factory applied coatings for exterior metal coating product. I would like to suggest before we get into the program, that you have what you need to be able to take notes and jot down some of the main bullet points, including the key takeaways. These will also be, there will be an open question and answer sections after the completion of that presentation. Okay. Now it is important to differentiate what coil coating products are and what some of the other Sherwin-Williams divisions products are. This way you will have a greater understanding of where to turn for expertise, where you need assistance in specification or sampling of the paint and coating products for your projects. So coil coating and extrusion coating are factory applied coatings, okay? And it's not for field applied coatings. So let's say for, for your building, for your project, if it's for the interior wall, we don't supply, I mean, our division does not supply that coating, but it's another business unit, all right? So we only supply the coating for factory applied coatings. And we only supply the coatings for exterior metal building products only, okay? It's for building, for the metal part, not for the halls and walls. And our coating we're talking about today is going to be cured at very high temperature. So it's not for air dry product, all right? And most of our product is liquid. For coil coating is mainly, is 100% liquid. Now for extrusion, maybe it's for powder, but we, as Sherwin-Williams today, we don't supply powder coating for that application at this point. So why Sherwin-Williams coil coating? Because we have the color, responsiveness, and innovation. These are the three critical considerations for architects and your projects. With the database of like more than 55,000 colors that we have, we can create more than 5,000 custom extrusion matches every year, all right? And we can also have 250,000 panels in our lab for your immediate needs. So if you do have any color matches, send in a panel or give us a call. We can try to send out the panels that we have in our lab to meet your needs. Okay, so that's what we're trying to do here. To save you the time to match the colors. Okay, so that's what we try to do. So today we'll be focusing on our highest performance factory applied metal coating for the building envelopes. So mainly is 70% PVDF. So sometimes people are asking what PVDF is. It is a thermoplastic coating which can be expanded and contract with the metal substrate and provides superior performance for color and weather barrier. So the American Architectural Manufacturer Association, referred as AAMA, the ARMA, is a third-party independent organization that sets the standard for the building facade and fenestration. PVDF exceeds ARMA's 2605 standard and can be applied to coil and extrusion metal components. So let's join me in taking a deeper dive into our color section as we watch a brief video. So as you can see, Sherwin-Williams coil coatings, we're obsessed with color. It's evidence in all that we do, okay? So let's get started so that you will know how to incorporate color with coil and extrusion coatings into your next project. Okay, on the screen, you can see is my team here in China. I'm Shu Li, okay? I'm the technical director for coil and extrusion coating, and I'm based in Shanghai. So on the screen, you see my 3 colleagues, Sophie, Alicia, and Liang Liang. And Sophie and Alicia are marketing, and Liang Liang is the salesperson responsible for Hong Kong and South China as well. Okay, so if you do have any requests or questions, feel free to contact one of us, either by email, phone, or text. Or sometimes, if you do have video chats, feel free to do so. So we're here to help you. Now, before we kick off the AIA content, I'd like for you to take a look at the facade on the next few slides. What do they all have in common? Do you recognize any of these buildings? If you say color and metal, you're right. All of these buildings projects use color and coated panels to create visual dynamic facades today. So we're going to talk about how you can incorporate coil and extrusion coatings into your designs to make a big impact on your next project. So again, this presentation is protected by US international copyright laws. So I just want to re-emphasize this. So I'm not going to spend a lot of time on that. Okay. So today we only have like 4 learning objectives. Okay. One is to understand what coil and extrusion coatings are and why they matter. Number 2, to review coil and extrusion coating methods and end-use applications. Number 3, explore how color and metal coatings can be used to design visually impactful building facades. And number 4, to discuss coating performance and how to specify the right coating for your next project. So these 4 learning objectives will cover off on what the coatings are and why they matter, how they work and where to apply them, what options are available, and when to use which type of coatings. So now we're moving into objective 1. Okay, try to understand what coil and extrusion coatings are and why they matter. So when we talk about coatings, coil coatings and extrusion coatings, okay, we're talking about a very thin film to provide us the visual impact. And not just the visual impact in practice, okay? In reality, the film that we provide on the surface of the metal, it has provided not just color, but also some corrosion resistance to the metal as well. Okay, so that's what our coating is. Let's move on. So today we'll be learning about the coating known as 70% PVDF. It is important to understand the ingredients of this coating and what role each plays in the overall system. So we're talking about the pigment, we talk about the resin, we have solvent, and we have additives in the coating as components. Okay. Now the pigment supplies the color and opacity to hide the substrate to achieve nice even color across the entire surface. So the pigment, we call it the brand of your building because it is what adds visual life to your facade. Now the resin as the binder is to hold the coating together and play a significant role in the overall performance properties of the coating. So you're talking about later on when we talk about coil coating, and we have to fabricate after we coated the panel. Okay, so we talk about the flexibility, or we talk about the weatherability. These all come from the resin itself. Solvent or the thinner that makes the pigment and resin easier to apply and provide application properties. So let's say for our coatings that we use for our walls at home, so that's consumer paint, okay? And the solvent here is water, okay? So we adjust that material to the right viscosity that we can apply. We can roll or brush, apply on our walls. But for coil coating and the extrusion coating, now, due to this different application process, we have to adjust our coatings to different viscosity to fit for that process. Okay, so that's the solvent part of it. Now the additive are supplements to the formulation that added in very small quantities, but it's very important to provide special characteristics such as texture or abrasion resistance, or even making the surface look very nice. So without the additives, we can see some, we might expect all kinds of different defects on the surface. Okay, so the additives are very small quantity, but it is very important to the formula. And now we talk about the pigment, all right? Pigments, we have like so many different types of pigments. We talk about the organic pigment, we talk about the inorganic pigment. And sometimes we have like special effect pigments, okay? So when we talk about solid colors, and solid colors that we color match with the organic pigment or inorganic pigments. So organic pigment is carbon-based pigment and is less color stability. We can achieve the very bright color from those organic pigment, but since it's less stable and it's very sensitive to heat, okay, it's very difficult to manage when we during the coating process. And also because of its color, it's carbon-based, okay, and is so the weatherability is not as good as inorganic. All right. Now, when it comes to a project that require a longer warranty based on organic pigment, we have to use a clear coat to protect the colors. Otherwise, I mean, the color will be very easily, probably like 2 or 3 years. It changed the shade of it, okay? That's the downside of the organic pigment. Now, inorganic pigment is different. Inorganic pigment is mineral-based and often made from metal oxides. So the color is not as bright as the organic pigment, but it is very color stay stable, all right? You're talking about long-term, you're talking about 20-year warranty or 35-year warranty or whatever, this color pigment will stay very close to the original color. So if we're using the inorganic pigment for your projects, we don't normally have to use the 3-coat system. 2-coat system can meet the requirement on that for your project. Okay. And then the solvent, as I mentioned, solvent comprise the majority of the total coating system, and is where the VOC, we're talking about the volatile organic compounds, can be found, okay? So when we talk about the coating itself, I think 30 to 40% of the formula are these organic solvent. So during the baking process, this solvent will be evaporated. And for coil coating and extrusion coating, most of these organic solvent will be captured and also burned to use as heating source for the oven. So these aspect of the factory applied finish means that it does not emit any harmful toxin or off gases into the atmosphere as a result. Okay. When the solvent evaporates, the resin binds the pigment and color and additive to form the film. And specific to the application, additives are used for processing pigment within the film for flow and smoothness, for regulating the rate of cure, and for enhancing the cure hardness, gloss, and mold resistance, and other performance attributes. So a lot of these terms that you may not be familiar with, but we talk about, if you're looking at the panel, I think Florence showed us the panel, like the black color, okay? If you look at the panel, it's smoothed out and very evenly distributed. And that's the effect of these additives, okay? To make the flow a lot better, make the surface look so much smooth, okay? And very glossy. And some of them are actually improve the cure of the film, okay? Without the additives, this reaction will not happen. So that's what the additives does in the formula. And resin, as I mentioned, is one of the most important component in the coating product. If we use the resin as a binder, okay, to wet the pigment, to protect the pigment as well, okay, and also to provide the physical properties of that film that we can fabricate the parts, and in that event, because during the installation, a lot of scratches may happen. So that's why we need to consider the hardness of this coating surface to meet specific requirement, okay, to avoid most of the scratches during the installation. So, and also because I mentioned before, resin is also provide the durability and the exterior weathering properties to the coating. So if the resin is not good, then we're expecting a lot of chalking happening during the, over time because of the sunlight. Yeah. So the resin binder got downgraded and causing chalking happen. And it also protects the pigment from the sunlight as well. So to maintain the color of the finished good to be to stay as the original as long as it is. Okay, so when we talk about the resin here, especially in the 70% PVDF, we're known as the brands, we're known as like Kaina from Arkema and Hyla from Solvay. These are the two most known brands for the resin, for the PVDF resin. And these resin have no color. Okay. And I also want to tell you that it's important not to understand that 70% here is not representing 70% of the total formula. I'm talking about 70% PVDF. That means within the entire formulation of the coating, there's about maybe 50% of that is resin. So 70% of that 50% is PVDF. And the remaining 30% is acrylic. Okay. So why are we using 70% coating, PVDF coating for metal? Because three key factors is performance, aesthetics, and sustainability. As I mentioned earlier, 70% PVDF product or coating exceeds the highest performance standard for ARMA 2605. Now we're matching over 5,000 colors every year for the facades. And because of the factory application, so there's no harmful material or even like the VOC emitted into the atmosphere, okay? There are also, if we're talking about to meet the LBC or LEED version 4.1 project requirements, we can formulate specific product to meet that requirement, okay? So that's 70% PVDF. We can also work with that LEED standard. So for this example, the Pope Penguin Conservation Center, this is in Detroit, Michigan. When we initially work with that project, okay, and there's a group of designers to get together, try to simulate the color of the building to like the North Pole, okay, the ice effect, I would say that, okay. So at the beginning, we consider some of the let's say the color changing effect, like the chameleon, all right. And then later on, we decided to use the FLUROPON Classic 2, the special effect, to simulate that color. And right now, it turned out to be a very successful project. It's very, a lot of people look at the outside of that building, and the first impression is it's very how to say that? When they're looking at the North Pole ice or snow, that's how the impression they got. Okay, so it became a very successful project, and to a lot of people, this visual impact is very strong. All right. So now we talk about the major components of the coating and why it is important to use the 70% PVDF. And now let's discuss how coil and extrusion coatings are applied. Now you can see on top is coil coating, okay? So we talk about coil coating usually applied over hot dip galvanized or galvalume or aluminum in a continuous automated process. Now the coated panels is then fabricated into building products. And that's an easy way to remember is coil coating is you coat it, then create it. With extrusion, is spray applied to extruded aluminum profiles and is post-forming, okay? So for extrusion coating is the reverse, is you create it, then coat it. So that's the major difference between these two, coil coating and extrusion coating. But both are applied by approved applicators and require high temperatures to cure. Coil coatings are applied in factory in a continuous process to flat sheet of metal. So typically is a whole roll, big roll of coil metal and on coil, and then I'll talk about the process a little bit later. Okay.
This is Vicky. I just want to make sure we have about 20 minutes left. I just want to make sure we get to the good stuff as well, the case study. So I just want to keep track of our time.
All right. Let me speed up a little bit. So coil coated metal is used in a wide variety of the industry, including building products, appliance, and transportation, and a range of other manufacturing products. So as it relates to the architects, you most typically see coil used for metal walls, panel, and metal roofing, all right? Now this is the coil coating line, if you can see the beginning to the end. So the whole coil, uncoil, and then go through the pre-treatment section. And then we have the primer coating section and the top coat coating section. And once it's finished, it goes through the oven and go through the water quench and recoil. Okay, so that's the whole process for coil coating. And the line speed here, it could be range from 30 meters per minute to about 220 meters per minute. It depends on what substrate and how the line is designed. So the speed is very fast, and it's 24 hours operating, continuous coating. So at the end of the recoil, all colors are already applied and cured. So that's the process. For extrusion application, it's mainly used for curtain walls and louvers, fins, and windows door frames. And these are the parts that they form it and then use our paint and spray apply it. So get going. And you can see this line, okay? This is a extrusion coating line. So the parts loaded to the pre-treatment section as well. It basically is going through the whole process again, but it's hanging on the parts, go through the pre-treatment, and then spray 3 layers of coating, wet and wet, mainly, and then go through the oven. When it comes out through the oven, then it becomes 100% pure. Then we can take it off the shelf and then ship to the construction site. So that's the whole process. So from this picture, you can see this National Museum of African American History and Culture. This is located in Washington. And this building, you can see, is very important landmark of the nation, and it's built on the last available spot on the National Mall, Washington, D.C. Now the bronze wash of the metal panel was a monumental component of the design, okay? So it contains 4 parts. One is the 3 custom shades, African sunset and African sunrise and African rose. And then 1 standard shade of black FLUROPON coating we use on the massive aluminum panel. That's how we form the outside walls of this project. Okay, so these are the key takeaways for the objective number 2. Now we move on to objective number 3. So let's see the video first. So from the video, you can see that it's the color matters, okay? So you can see here, the 2 great real-world examples to show the impact of the color can have a success of the building, okay? So from the picture on the left, 3 buildings standing are exactly the same looking. And initially, one company occupied these 3 buildings. But after they moved out, they tried to find the new tenants to occupy those buildings. And it's very difficult to do that because not every company can afford to rent 3 buildings altogether, okay? So at the end, they hire a color company to do a different design of the outside look of these 3 buildings, and they ended up looking as the picture on the right. Okay, so then you have different color of the wall panels. One is like blue, grays, and white. Okay. Then to create the color is no longer blended into other skylines. The color gives a facade a unique look of their own. Now occupancy has soared in these buildings as a result. So color is, I mean, when we look at the things that first impression is visual, okay? You don't get a second chance to make a good first impression. For the most part, and in architectural, color can play a big part in how the public views the building as well. So color means, which it can be a brand recognition for the building as well. So when we think about the Golden Gate Bridge, okay, and what about Coca-Cola logo? So these brands and associated with color. Now, sunshades, louvers, and fins are exterior adornment to the structure, like jewelry with a purpose. The ability to provide layers, colorful accents, creating shadow and visual movement gives you the opportunity to incorporate color on many planes. So look at all these buildings. If color, without the color, I mean, all these buildings without the design colors, and they just look like another building along the highway, all right? So now you can see how coated metal building products can contribute to your design. Let's review some of the aesthetic effect that you can achieve with coil and coating, coil and extrusion coatings. Yeah, mica metallic coatings are very common and provide outstanding weathering performance. So mica and metallic are a blend of mica and aluminum pigmentation that adds the degree of sparkles to the surface. So since it's, the mica is inherently UV stable, so it can often provide with the two-coat system. Metallic, because it's aluminum flakes, which is not UV stable and require a clear coat to make it a three-coat system as a protection. So these are three examples that use the mica two-coat system. We talk about the Hong Kong Convention Center, and then two other projects on this picture as well. Okay, these are the projects using the mica product. Next one is the color shifting. Okay. Color shifting pigmentation works when viewed from different angle or under changing light sources. So you can see that if you're standing at one angle, you look at it as red, but if you stand, let's say, 15 meters away or changing a different angle, the color could be shifting from red to green, and in the middle, you see yellow. So that's how these color shifting pigmentation works. So here's an example of the actual building with the color shifting pigment. I'm not going to get into a lot of details for that, but that's how how we design these projects to simulate or to blend in to certain environment to make the project look very good. And this one is the high intensity sparkle to simulate what we can see on the night sky, a lot of stars, bright stars. That's what we intend to do. And that's why we come up with that high intensity sparkle. And the actual project here is the New Bund Center in Shanghai, and it's designed by KPF. Again, this project is using an intense sparkle 70% PVDF product to make it look very, very good and very nice at night, especially with the lights. Now we can also have a different kind of effect, like coil prints. Okay, so that we can we use a special design rollers to apply these inks on top of the base coat, and then we use the clear coat to protect these inks. So to maintain the shape and the color of this nice looking prints on the coil coating lines. And again, I mean, from the earlier picture from Florence, you can see the black, some of them high gloss. And for PVDF, we cannot achieve the higher gloss than, like, let's say 40 gloss. It's very difficult to achieve, even with the coil coating or extrusion, okay? So that's the nature of the 70% PVDF. We cannot achieve the high gloss. But changing to FEVE, we can achieve the higher gloss, and with some other additives of different pigment, we can achieve different texture of the surface as well. So it depends on how you want to design for your project. We can meet your needs based on the texture and the gloss. Okay, so these are the 5 key takeaways. I'm not going to go through one by one due to the timing. So let's move on to the next objective. Okay, so you're on the number 4, what you'll be learning about the coating performance and how to specify the right one for your next project. So let's see the video first. Because our product mainly used for exterior, so the coating performance and weathering is very important to your projects. Now, the factors that come into effect of the lifespan of our product is, let's say, the exposure to sun, mainly due to the UV light. What about the salt spray? I'm talking about close to the sea water. What about acid rain? The moisture and humidity in the air, and what about the temperature fluctuation during the day and night? So these factors can lead to the chalking and fading of the coating itself. So that's why when we design these coatings for your projects, we use a lot of testing methodologies to study the lifespan of our coatings. Outdoor exposure is one of the very important tests that we use, okay? So we have a fence that in Fort Myers that containing over 150,000 panels, okay? So these panels are exposed 45 degrees to the sun. That way exposed to the UV light, and also because it's in Florida, close to the ocean. So we also evaluating the corrosion performance of that coating as well. Okay, and the longest panel in there is over 60 years old already, close to be 60. Okay, and the 70% that from the result, okay, 70% PVDF is superior performance coating based on that knowledge. Okay, because we're going back to review the color and chalking, fading of those panels every year. And also, besides the actual outdoor exposure, we also have the lab to do accelerated testing, try to correlate these two to speed up the test so that we can come up with a quicker solution for a lot of your projects. So again, I mean, we have been talking about 70% PVDF coating for metal. And why? And because of its performance and the aesthetic result and the sustainability. Okay, so we repeating that also. And here, because the 70% PVDF exceeded the ARMA 2605 standard. Now for coating itself, it has a lot of other products like polyester acrylics and powder coating. You're talking about powder coating mainly is acrylic and polyester as well. But the performance is not near as the 70% PVDF, okay? So where should you be specifying factory applied coatings? Here are the CSI categories within master spec or BSD spec link specification where ARMA 2605 coatings can be specified. So Division 5 is sharp applied coatings is equivalent to Division 9, but for factory applied coatings. Now Division 7 is for thermal and moisture, where you find the coil and use applications. And Division 8 is doors and windows, where you find the extrusion and use applications. Okay, so it's important to note that the coating will always be specified alongside the building products. There are a number of factors that comes into play when selecting the best coating for your project need. The most important takeaway here is that you work with your coating representative to ensure that you're selecting the right system in the schematic design phase. The most important of these are the location of your project, the color selected, and the end use application. Now, should you be working on a project that requires a credit for LBC or LEED 4.1, understand that there are sustainable coating options that you may want to consider, okay? Due to the time limit, I'm not gonna talk a lot of that selection, but I just want to give you an example that we're working on a project and the designer come up with the idea to use like bright red color. And when we got contacted from that designer for that color selection, we told them that that color will not stand long enough for the warranty because we have to use organic pigment. So these kind of work correlation is needed to shorten your design time to speed up your decision as well. Okay. Otherwise, I mean, you ask for a bright red color match, and then we match the color to you, and then we later on we tell you we will not provide the warranty for that color. So that will end up you wasting your time for your project. Okay. So these are the key takeaways for these objective as well. Okay. I mean, that's the end of the presentation, and these are the learning objective reviews. Do we want to go through these questions one by one?
Wow, now you got all the answers.
All right, so that's the end of my presentation. Open for the questions.
Well, thank you, Mr. Li, for the presentations. I think after this 1 hour presentation, you guys all know why he's my friend, because he's very serious about his business. We welcome any questions. You can post it at the bottom of the Zoom. Oh, I have I'm seeing like two questions here. The first one, Mr. Li, is about a member is asking, can he or she has two colors applied to the same extrusions?
Now the same extrusion, talking about the one
piece. Yeah, I think one piece.
It can, but it takes a lot of different process. Seems like there are two ways to do that. One is we decided the second color can hide the first color. That means we can spray the first color on, and then when it comes around, that we can tape off one section and then spray the second color on top of that. That's one way of doing it.
Just like we make our models.
Yeah. Second way to do it is we tape off the section and then spray the first color, and then again we tape off the first color first and then spray the second part of it. So it's like it's process. We can process it, but it takes a lot of effort.
But do you like spray on it and then you bake it and then you remove the protection and then you spray on it and then you bake it again?
Right, we have to do that, yes.
Okay, all right. So the second question I have here is, what is the relationship between 70% PVDF and FEVE?
All right, 70% PVDF is thermoplastic film. Okay, it doesn't react. It does not have any reaction during the curing process. So the film is relatively soft, and the gloss is not. We cannot achieve the high gloss based on the 70% PVDF. Okay. Now the FEVE is a thermoset resin. So when it's baked, it reacts to another through the cross linker to form the film. All right. Now the difference between these two, it's just basically it's just like one for FEVE, we can achieve 70 gloss. Okay, 70 gloss for the FEVE, but 70% PVDF, we can only achieve as high as 40 gloss.
I see. Yeah. How much more expensive? Oh, okay, that's the third question. How much more expensive is the FEVE coating compared to a PVDF? Gosh, I think I'm like being like the biggest supporter of your FEVE. Now everyone is asking about it.
How much more expensive? Because of that resin is at least 20–30% more expensive than PVDF. Okay, so you're talking about the finished good, it's around like 20–30% higher price than the PVDF. Now,
and how about is there a way to touch up if it is scratched?
I would suggest, yes, definitely, okay. Put it this way, our touch up paint for PVDF today is FEVE. So if it's FEVE to start with, we can always touch up with that. That's not a problem.
Great. Well, since we are kind of like overrun already, so I don't want to keep everyone here for too long, but I just want to give you guys an update, even though like I assume many of you are being like stuck at home right now, but we are planning a lot of events that's going to happen, and with Sherwin-Williams, we are definitely trying to plan an event of like visiting one of those factories, doing the coating sometimes next year. Hopefully by that time, COVID will be gone, and then we will be able to go to one of those factories, seeing the real the application lines that the diagram Mr. Li was showing. Personally, I've been one of them, and I thought it was really exciting to see the things, how it gets done, and you get a much better impression about how things goes. And so that's one thing. And then the next one that I want to remind you is the next webinar from AIA Hong Kong chapter is coming up in middle of August. And it is not a technical seminar, but something about landscape design. And then it will be presented by Stephen Cantor, who is a writer who has just published a book on landscape architecture. And then there's going to be joined by Matthew Pryler, who is the head of landscape architecture department at the Chinese University of Hong Kong. So thank you again for joining us for tonight's event. I hope you have a good evening. Thank you.
Thank you.